Hello, my name is Kyle Carter, and here I'll be discussing lab number 8 on the synchronous hexadecimal counter. So the problem that I had in this lab was my DE10 light board. It would be plugged in all the way, and it still doesn't turn on. So it says that it works on my computer. Like it says that the progress was successful. I could start it and all, but it just wouldn't it said it would be successful, but like it doesn't turn on. But like when like I could like tug it a little bit and like tap it sometimes, and then like it will turn on and off. So like let me see if I can show. Like if I like tug it, like it's like something wrong with the cord, I'm guessing. But so like if I position the cord a little bit the right way, it turns on, but it doesn't turn on for a while. Like it turns on and off. Like something's wrong with the cord, and it's not letting me, or something wrong with the board itself, because it's saying that it's like going on. Like it said that it ran on here, but it's just not letting me run it on the thing itself. Like if I just keep moving it, like tapping it, it will turn on and off, but it doesn't stay on there for long. So what I was able, like the information that I was able to gather while doing this lab was, if it was being compared, to the asynchronous counter, the synchronous counter has one global clock, and I was able to realize that I read a couple of documents and I was able to gather some of this information. The synchronous counter has one global clock which drives each flip-flop, so the output changes in parallel. And the one advantage that the synchronous counter has over the asynchronous counter is that it can operate on a higher frequency than the asynchronous counter, as it does not have a cumulative delay because of the same clock is given to each flip-flop. And the count sequence is controlled using logic gates. Overall, faster operations may be achieved as opposed to the synchronous counter. The synchronous counters can be made of toggle or D flip-flops, and D flip-flops were used in this lab, or were used in this lab itself, as well as the one we did last week. The synchronous counters are easier to design as opposed to the asynchronous, and they're called synchronous counters because the clock input of its flip-flops are all clocked together at the same time, which and they all have the same clock signal. And due to this common clock pulse, all of the output states switch or they change simultaneously, and the inherited memory circuit, it keeps track of the counter's present state. So for the circuit in the diagram, so like Q0, the bit gives response to each of the following edge of the clock, while Q1 is dependent on Q0 and Q2. That's just an example. And Q2 is dependent on Q1 and Q0, and Q3 is dependent on Q2, Q1, and Q0. So it's dependent on the ones that that occur prior to it. Like all of them are tended to the ones that occur prior to them. The D flip-flop, it tracks the input and it makes transitions with those on the input of the D itself. The D stands for data, and this flip-flop stores the value that is on each data line. And that is how I was able to conduct this lab. I was not able to output anything because, like I said, the DE10 light board is not really working for me. I contacted them last week in regards to it. So I contacted them on Thursday because that's when we had the lab, and I was able to see that it wasn't working then. But they haven't got back to me in regards to the problem. I think they said, well, they haven't contacted me back, but I'm going to call them back to see if they can send me a new cord, because I know we have the final on Thursday. But I do apologize for that, and I hope I don't get that many points deducted for that. Thank you.